I want to talk about an expansion of base times height. And we're going to start with the argument of the area of a rectangle versus the area of a parallelogram. Now this rectangle and the parallelogram have the exact same base, and they also have the exact same height. So we're taught that the area of both these things is going to just be base times height. And the reason why that's true is if you look at the slices of this rectangle and also the slices of the parallelogram, no matter where you slice these slices are equal. So really you can think about the area as the sum of all the slices, which is very much a calculus 2 idea. Now this also expands to maybe the volume of a cube, or even a rectangular prism if we want to call this. If I want to find its volume, well, its volume simply is going to be, base times height. Now the base of this thing is going to be this right here. And what I know is if I'm looking at this base, if I slice it there or if I slice it here, that the base is unchanged no matter where I slice this. So if I want to talk about the base, let's call this length times width, so that's going to be equal to our base, times our height. So then the volume is going to be equal to length times width times your height. The last thing we could talk about is what about a cylinder? So if I look at a cylinder, we can see something that looks like this. If I want to know this thing's volume or how much it contains, we can also tell that this is going to be equal to its base times its height. So that means the volume here is going to be equal to base times height. Well, the base is a circle, so this is going to be pi r squared times its height, which is equal to h. And if you look at a child's toy, like a slinky, we can see that how much is in this thing wouldn't matter if I sheared it or even sheared it backwards, that how much water this thing would contain would remain the same no matter how much you shear it. Please subscribe.